so we are at the end of chapter 12. Yay! And we get to end on an easy note. And then you need to do the review. But real easy note, unit 8 notes. The notes are short, the worksheet is short, the notes is just the front side, and the worksheet is just the front side. So let's get started. This is basically rate of change, and rate of change is really basically your slope. We all know how to find slope of a line, and slope of a line is consistent no matter what. And so you've done a lot of rate of change in Advanced Math 8 and Math 1, but rate of change is not consistent for anything that is a quadratic, which is our x squared, or exponential graphs. Rate of change for exponential graphs are growing exponentially, like the coronavirus. But let's talk about rate of change for quadratics. So we are going to go through and we're just going to do a table for these two equations. No graph, but just a table. And basically I just picked points to plug in. So I'm going to plug in 1 into the f of x equation. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now if you guys remember, we would know this is a quadratic because it's increasing by 3, 5, 7, and 9. And then if you go farther, these are all going out by 2's. Not real important, but just so you know. And then if we do this, we're going to do order of operations. So 3 times whatever squared. So 3 times 1 squared would be 1 times 3, which is 3. 3 times 2 squared, which would be 3 times 4, which is 12. And so basically each time we're going to go 3 times 9, which is 27. 3 times 16, which is 48. And 3 times 25, which is 75. So basically every single one of these are 3 times as big. So we're going to figure out the average rate of change for just f of x, from x equals 1 to x equals 3. Well, if you know slope is y2 minus y1 over x2 minus x1. Or in this case, it's going to be the same thing, but this is going to be the answer to the function, so f of x and g of x. And so it really doesn't matter which one you make x1 and y1, but we're going to go 1 to 3. So if you look at 1, the point is 1, 1. And if you look at 3, the point is 3, 9. So I'm going to make this x1, y1, x2, y2, and I'm going to find the slope. So 9 minus 1 over 3 minus 1, 8 over 2, which is 4. Okay. Now the slope of a parabola or a quadratic, these u's are not consistent, like a line. And as you go farther and farther up the graph, the slope should get bigger. And let's figure out the slope for the other graph just the same. Now you probably would thinking that maybe this is going to be 3 times as much as, which is 12, which you're right. But let's just do it. So the point 1, 3 off the g equation, excuse me, the point 3, 27, make this x1, y1, x2, y2. So 27 minus 3 over 3 minus 1. You notice this isn't any different. And that's 24 over 2, which is 12. Makes sense, it's 3 times as much. So it says the average rates of change are different. What does this mean about the relationship of the graph? Well, that means the g of x equation, or graph, is more narrow of a graph. Remember that 3 in front? And it's increasing, at least the y values, a lot faster. Okay, so let's do the same thing with the next one. So we're going to do the same thing, but we're going to do it from 3 to 5. Now you think, well, it's going to be 4. Not really. So if we do 3 to 5, the point 3, 9, this is the f of x, so 3, 9, and 5, 25. This is x1, y1, whoops, x2, y2. So 25 minus 9 over 5 minus 3. That's 16 over 2, which is 8. This is different than the 4. It's actually twice as much. Okay, and so It's increasing. Why? Because if you think about a U graph, it's getting steeper here. And so this is why this number's up here are steeper than the numbers down here. And we're going to do the same thing for g of x. So g of x, we have the point 327 and 525. And you guys might say, oh, well, it's going to be 3 times as much as 24. And you would be right, but we're going to go through x1, y1, x2, y2. Whoops, that's not 25, that's 75, sorry. So 75 minus 27 over 5 minus 3. 75 minus 27 is 48 over 2, which is 24. It's going up very, very fast between those 2 points. So they are different. Again, the g of x is increasing faster. Oops, faster. And faster, the farther you get away from the vertex. Let's make sure you guys can see this. So if we started doing other points like 7 to 9, it'd be bigger because the graph is getting narrower and wider. That's all there is to those notes. The next thing you guys have to do is the review. And the review is going to have everything from the chapter, and then we'll start our next chapter. And I might be wrong. You may not even have a review. Do you have a review? You should. Right? I gotta double check that. Hold on. Yeah, you guys have a review. So the next thing we'll review just to double check, because we're not doing tests, so you guys got to make sure that you're doing the reviews to double check your knowledge of the whole chapter. Anytime you have a question, let me know. Good luck. See you guys soon. Bye.